Hi everyone, my name is Daniel Worsnup and this is a JavaScript coding tutorial. Today we'll be talking about the Promise.all function and we'll be implementing it in order to get a better idea of how it works under the hood. So if you're not familiar with promises or asynchronous programming in JavaScript, then I recommend that you pause this video and go learn about those ideas first, as that context is going to be very useful in following along. Just to summarize, a promise is an object in JavaScript that enables us to wait for some future event, and then when that event happens, we can run some code. So usually when you have a promise, you're waiting for a single unit of action to complete. But what Promise.all enables us to do is wait for multiple promises to complete. And it basically takes an array of promises as input and returns a promise that you can think of as the wrapping promise. So when the promise that is returned from Promise.all resolves, that means that all of the promises that you pass to Promise.all have resolved. And if any of the promises that you pass to Promise.all reject, then Promise.all itself will reject because it requires that all of the promises that you pass to it to resolve in order for it to resolve. So I've created this code sandbox over here, which will enable us to see the behavior of Promise.all in a visual way. So I'm not going to dive too deep into the UI code for this. What's really important is that we're creating three promises here. We'll call them Promise A, Promise B, and Promise C. And you can see that as of right now, all of the promises are not started. And then we have all promises here, and all promises represents calling the result of calling Promise.all on promises A, B, and C. So if we look over here in this source file, get promises, and what it does is it returns three items in an array. And the items in the array are the results of calling the wait function. And the wait function is just a little utility that I have written. Well, we can just take a look at it. So what we have here is a very simple wait function that takes a duration, result, and should reject as parameters. And it sets a timeout in order to resolve the promise that it returns at some point in the future. And the specific amount of time in the future that the promise will resolve or reject is specified by the duration parameter. And then the result parameter specifies the value that the promise should resolve or reject to. And then the should reject Boolean represents whether or not this promise should reject or resolve. So we're going to start off just focusing on the resolve case, but at some point later in the tutorial, we'll look at also handling when promises reject, because when you pass an array of promises to Promise.all and one of them rejects, then Promise.all itself will reject. So let's go back to get promises. So you can see here promise number one, which is promise A, is going to resolve after 1.5 seconds with the value 0. Then element 2 of the array, which is promise B, is going to resolve after 500 milliseconds with 1 as the resolve value. And then the third promise, which is promise C, will resolve after 1 second with the value 2. So if I go over here and I click start, you can see that promise B resolves with 1 because it was 500. Promise C resolved with 2 because it was 1,000 milliseconds, and then promise A resolved with 0 because it was 1,500 milliseconds, and then all promises resolved, and you can see that they resolved with 0, 1, and 2. So just to make it a little bit more obvious, let me increase the amount of time. So let's make promise A resolve after 3,000, 2,000, 1,000. So we should see promise C, B, A resolve in that order. And then after they all resolve, we'll get all promises to be resolved. So we click start, you can see we get C, B, A, and then at the same time that A resolves, all promises have resolved in that moment, and so the all promises resolves. Now, just for demonstrative purposes, what if we pass should reject to promise B? So now what's going to happen is promise A will resolve after 1,000 milliseconds, promise B will reject after 2,000 milliseconds, and at the point that promise B rejects, Promise.all no longer cares what happens to promise A at all, right here. So even though promise A will eventually resolve successfully, the all promises promise, which is what we return from Promise.all, will have already rejected at that point. So let's hit start. you can see we get C, and then B rejects, and then eventually A did resolve, but that doesn't matter because since B rejected, the all promises has rejected, and you can see that it rejected with value 1. So like if I tell it to reject with true, then that's what we'll get. Rejected true. So let's get rid of our should reject and focus just on resolving promises. So I'm not going to dive deep into the code that I have in index.js. It's basically the UI code with our pending, resolve, rejected states, and so on and so forth. The important part is this 4 lines of code here is what controls the UI for the all promises box down here. And so you can see I'm calling Promise.all. I'm not calling Promise.all. I'm calling this Promise.all function. And then depending on whether the Promise.all function resolves or rejects, I'm setting the state of all promises to resolved or rejected. So what we need to look at really is what is Promise.all. So I'm importing Promise.all from this Promise.all file, which is right here. And so you can see right now, all Promise.all.js is doing is calling Promise.all. So we're seeing the default browser, the native Promise.all behavior over here. So C, B, A, and all resolved. But what we're going to do is we're going to re-implement Promise.all in this file, and we're going to make sure that we maintain the same functionality as the native Promise.all. And the goal of this exercise is simply to understand a little bit better how Promise.all works. So in order to understand that a little bit better, let's just go ahead and take a look at the docs here. So if we look at the syntax, Promise.all takes an iterable. We're going to start off by assuming that the parameter to Promise.all is an array. And then at the end of the video, we'll make a really small change which will support any iterable object. There is an important distinction between an array and an iterable, and you can kind of see the docs are already hinting at it here. An array is a very specific native object in JavaScript, whereas an iterable is just an interface that any object can implement. So all you have to do is implement this symbol.iterator on an object, and then technically it becomes an iterable and can be passed into Promise.all. But we're not going to worry about that right now. We're going to start off by assuming that we just have an array of promises passed in here. So let's just call it promises for now. Let's just take a look at the docs again. If we scroll down here, there's a very important detail that we want to take into account right off the bat, which is that if no promises get passed in, Promise.all immediately returns a resolved promise because it has nothing to wait for. It has no work to do. So what we can do here is we can just check promises.length 0, and if that's the case, we can just return promise.resolve right away and empty array. So let's save that. So this handles the case where no promises are passed in, but much more importantly, we need to handle the many infinite possible cases where promises are passed in, and we need to wait for these promises to either resolve or reject, and depending on whether or not they resolve or reject, we then resolve or reject the outer promise, and if we resolve the outer promise, then we resolve it with a very specific value, which is the results of all the promises that were passed in and have resolved. So Promise.all returns an outer promise. And let's just focus on resolve right now, and we'll focus on reject later. It returns this outer promise, and we want to call resolve on this outer promise when all of these promises have resolved. So we're going to have to iterate over all of these promises and attach a then handler to them so that we can run some code when they resolve one at a time. And then at some point, we're going to have to figure out, okay, that was the last promise we were waiting for to resolve. Now we can resolve the outer promise, which we'll do by calling this resolve function here. So let's just iterate over the promises for each, and we'll get a promise. And so now we have all of the promises one at a time, and we can attach a .then handler to the promise. And let's just say that we're going to get a result. And now the thing that is tricky about this is this code that we write in this function right here is executing at some point in the future. So we need to make sure that we handle the correct ordering of the results. So what I could try to do here is do results.push result, okay? So now every single time one of these promises resolves, and they're only going to resolve once. So whenever each of these promises resolve, we'll take the result, we'll push it into a results array, and then as soon as the last promise has resolved, we then need to resolve this outer promise with this resolve function with all of the results. So here's what we can do. We can just check to see if results.length is equal to promises.length, right? Because as soon as we push the last result into the results array, results is going to have the same number of elements as the number of promises that are passed into the function. And then we'll be able to resolve the outer promise. So we can call resolve, and we can just do results. And we've got an error. Oh, I've got a comma here. Okay. Now, okay, so we're definitely going to get a result here that may even look like it's working, but we need to examine very carefully to see if it's actually working. So let me just go ahead and do something here real quick. Let's bring back our original implementation of Promise.all that just passes all of the arguments to Promise.all. And this way we can see the native behavior. And what we'll do is we'll comment all this out, and we'll be able to compare the native behavior with our custom behavior. And we'll make sure that the visuals line up. So let's see what we're expecting here. We're expecting promise C to resolve first with a value 2, promise A to resolve second with a value of 0, and promise B to resolve third with a value 1. So if we click start, we get C2, A0, B1, all promises 0, 1, 2. Now it's very important to notice that the order of the results in all promises, which is the resolved value from Promise.all, is exactly the same order as the promises that we pass to Promise.all. So you notice that 0, 1, 2 are the results we're expecting in that order. That's what we should be seeing here. So with native Promise.all, thankfully, it's working and we're seeing that. But let's get rid of native Promise.all and bring back our custom Promise.all, save and run. So we get C2, A0, B1, but all promises is showing 2, 0, 1 instead of 0, 1, 2. And that's because of the way that we're handling the incoming promises as they resolve. Every single time a promise resolves, we push its result into the results array, and then we resolve the outer promise as soon as the results array length is the same as the promises array length. So we have the same number of results as promises. But the problem is that the order that the promises resolve is not necessarily the same order of the promises that are passed into Promise.all. Now, we could make it so it is that way, right? We could do 1,000, 2,000, 3,000, and we can start. And then we'll see 0, 1, 2, and then we'll see 0, 1, 2. But we can't assume that that's always going to be the case. We need to make sure that things are resolving and things are being returned in the right order. So 0, 1, 2, 1, 0, 2. So this needs to be 0, 1, 2. And the way that we need to do that is we can't just take the result of each promise as it resolves and throw it in an array. What we need to do is take the result of each promise as it resolves and somehow associate it with the promise that it resolved for. And then once all the promises resolve, and we'll still be able to use a similar check to this, we can then iterate over the array of promises, because that's the ordering that we need, is the ordering in that array of promises. We can iterate over that and then grab the result that's associated with each promise and create an array out of those results, because that's the correct order, and then return that array. So the way that we're going to do that is, instead of having a results array, we'll have a results map. And if you're not familiar with maps, go ahead and pause the video and go and take a look. A map essentially enables you to associate key value pairs where the keys can be objects. And that's what we're going to use, because the keys in our map are going to be the promises and the values are going to be the results. So instead of just pushing into the results array, now I need to set a value in the map, and the key is going to be the promise, the current promise that just resolved, and the value is going to be the result. And now instead of doing results.length, we need to check results.size, and then everything else stays the same. As soon as we have the right amount of results, we then want to resolve the outer promise. So I'm just going to create a function as sort of a utility. We're going to have a handle done, and then I'll implement this up here. Oops. So as soon as we're done, which means all the promises have resolved, we then need to resolve, right? We're going to resolve our outer promise. Oh, you know what? I made a couple of mistakes here. No big ones, but I should just move this code into our promise handler here. So we still want to resolve as soon as we're done, but instead of just resolving with the results is not an array anymore, it's a map. But we need to turn it back into an array. And the ordering of the array is important. It should be the same order as the promises that are passed into Promise.all. So what we'll do here is we'll just map the promises. And if you're not familiar with the map function, go and check that out. Essentially, we can run a function on each element of an array and produce a new array with the results of all the function calls, which is exactly what we need to do here. So for each promise in the promises array, we need to grab its result out of the results map. So we can just do results.getPromise. And if I'm not mistaken, that should solve our problem. So we have the right amount of results, we handle done, we map over the promises, and we get the result for each promise. Then map will return the new array containing all the results that should be in the right order. So let's see, we have 2. Okay, so we're expecting the resolution order to be 1, 0, 2, but the order of the resolved promise from Promise.all, yep, 1, 0, 2 is 0 and 2. So that's great. We've successfully handled the case that promises resolve in an unexpected order, or maybe an expected order, but that's really not the concern of Promise.all. Promise.all's main responsibility here is just to make sure that the array of results that it resolves to is a predictable order for the consumer. Okay, now we've handled empty array, and we've handled everything resolves, but we still need to handle something rejects. So let's just have promise A reject. So we'll change it to should reject true. And let's just go ahead and run and see what happens. Okay, so this is exactly what we would expect to see. Promise B and C did resolve, but promise A rejected. And so this if condition here, which is what's responsible for resolving the outer promise, never actually gets run because we never actually have the right amount of results, because one of the promises doesn't hit this success handler. So as you may know, .then, promise.then lets you pass the first parameter as the success function and lets you pass the second parameter as the error handler to handle the circumstance when the promise rejects. So let's go ahead and handle it. So when the promise resolves, we want to take the result, add it to the results map, and then check whether or not we should be resolving the outer promise. But when the promise rejects, if you remember from the behavior that we experienced earlier, the outer promise, the all promises promise, should reject right away. So let's go ahead and pass our reject function in here so that we can call it. And we just want to reject, like so. Now let's run it again. Perfect. So promise A rejected, and then as soon as it rejected, we saw that all promises rejected. And it also rejected with the correct value. We should see the same value that A rejected with is the value that Promise.all rejected with. There's one other thing that we can do here, which is that when we reject, we can just set a Boolean to true. And as soon as a promise rejects, we don't really need to handle any other promises coming in. It's possible that after a promise rejects, other promises will continue to resolve. And if they do so, we don't really care about that. We don't care about pushing anything into the results map or checking the results.size. So we can just return early here and not do anything. And let's just save that and run it again and make sure that we still have a functional solution. Okay, cool, perfect. Now, the one last thing that we're going to implement here is support for this iterable input. So if you recall, I mentioned earlier that Promise.all can also accept an iterable as its parameter, which means anything that can be iterated over using the iterator symbol and not just an array. So it's actually really easy for us to implement that. Let's just rename our parameter to iterable. And then let's make a promises array just by spreading the iterable into it. We could have come up with a much more complicated solution here, because you can iterate over an iterable by actually grabbing its iterator and calling .next on it, and then checking to see when it's done, so on and so forth. And I actually went through that process earlier when I was preparing this coding tutorial, and it really made all of this other logic extremely ugly and hard to reason about. I did have something that was functional, but it's nowhere near as clean as the solution that you get when you know that you're just dealing with an array. So this solution that handles iterables, all it does is it takes the iterable from the parameter and immediately creates an array out of it. So how can we check to see if this is working? What we need to do is change what we're passing to Promise.all. So instead of passing the array to Promise.all, let's pass a different iterable. And the easiest one that I can think of is just to create a new set out of promises. And this set, if we look up mdn set, the set is iterable. You can see it implements the iterator here. So that means that our Promise.all function will be able to spread the set into a new array, and everything else will just proceed to function as it already has been. And let's just test that out. 1, 0, rejected, 2. And that is pretty much it. We've implemented a Promise.all function that operates on par with the native Promise.all function. Hopefully you learned a couple of things about asynchronous programming, waiting for promises to resolve, maybe using a map to associate objects with other objects. In our case, objects with whatever the results are of the promises resolving. And that's it. Thanks for watching. Let me know what you think, and bye.